Hi and welcome to another very cool tutorial about the new programming language Swift, which was introduced only 2 days ago by Apple at WWDC 2014. Some of you had cool questions, which I'm going to answer in this video, like Benjamin, who would like to know how to use TableViews with Swift, or Luca, who wanted to know how to use Textfields in this new programming language. And there were some questions about the usage of _in, or the in statement, using blocks or closures, as they're called in Swift now. I'm going to explain all of that stuff with this cool application here. It doesn't do much, but it will illustrate many things you know from Objective-C transferred to the new syntax of Swift. So what is this application? What can we see here? We have a table view at the bottom here with a header view, which is black. In the header view, we have a nice text field with some placeholder text, which says enter your name, what I'm going to do now. So I click return and it says hello Brian. I can add another name like Steve, return, or Tim, and return. And when I click on one of the names, then I get this familiar alert view, which I can close, or I can click on change header color, which then changes the header color to a blue color using a nice animation. This app doesn't give you much of a use, but it will show you, as I said, many techniques you know from Objective-C, like delegation or blocks, closures, so that you can use all that stuff with Swift. So let's get started by opening a project that I already created. It's a single view application. The first thing we're going to do is accessing the main storyboard and changing a property of the view controller we're using. So I'm clicking on this view controller and deactivate the use auto layout for this tutorial, and we will just say disable size classes, keep size class data for iPhone. And now we have a standard iPhone 5 storyboard for this tutorial. And we will then use a table view and drag it right into our view controller. And then we will change some of the properties of this table view. We will give it one prototype cell, and we will then give this prototype cell an identifier so that we can later use the identifier in the cell for row at index path method. So let's name it cell identifier. All right. Now we can just access our assistant editor like we did in Objective when we wrote Objective-C code, and add a property to our view controller, which I will just call table view. Say connect, and that's it. Then let's access our viewcontroller.swift file and change this from nil to UI TableView so that it is initialized when we access it within the view.load method. And the first thing that we want to do is add a delegate and a data source. So let's say TableView delegate is self, and TableView.dataSource is self as well. Now we get an error here saying that type view controller does not conform to protocol UI TableView delegate. Let's change that and add those two delegates like UI TableView data source and UI TableView delegate. And then we get an error here because we do not conform to those protocols, because we haven't implemented the required methods yet. So let's change that and add the number of rows in section method at first. and return just 1 so that we don't get an error here. And then let's also add the number of sections in TableView method, which also returns 1. And we still need one delegate method, the TableView self-row index path method. Now I'm pasting them in because the auto completion of this version of Xcode for Swift isn't working properly yet. So let's return nil here and see if we get any errors. No builds succeeded. Great. Now let's add some logic to this. We first will need a data source sooner or later, so let's just create one. It's a var, and let's call it data source. Will be an NSMutable array. And let's also initialize it here using NSMutable array. All right, and you also saw here in our in this application that we are going to use a header view. So let's also create this header view right here, header view, which is a UI view, and also initialize it. All right, now what are we going to do about our table view number of rows in section? Well, as we would usually do it in Objective-C, we can just call our data source and let the data source count its elements. Now we have a number of rows in our section, and we can keep the number of sections, which will be 1 for the whole time. And now let's give our header view a little more space. So let's say header view.frame CG rectMake. It'll start at 0, 0 with the width of 320, which is the iPhone width, and let's say a height of 200 pixels. We will give it a background color, which will be a black color. And then let's say that we are going to use our header view as the header view of our table view. Looks pretty familiar. Well, now let's take a look at our finished app here. We will need a text field here. So we will just create one as we would with Objective-C, just with another syntax. Let's say name text field of type UI text field, and initialize it just with a frame CG rectMake. We'll start at 20, or let's just start at 0, 0 and place it to the center. 0, width 150, height 45. All right. Don't forget the closing parentheses. So now let's bring this text field to the center. So, name text field.center equals header view.center, which will place the text field exactly in the center of this header view. Let's continue with giving it another color. Let's say name text field.background color equals UI color white color. Let's center the text that is going to be written in this text field. So let's say text alignment equals and as text alignment dot center. And now let's add our placeholder text, name text field dot placeholder equals enter your name. Build it to see that there are no errors. Succeeded. And now to implement the return function, so that when I click on return on the keyboard, we're going to need the text field delegate, as we did with Objective-C. So let's give this text field its delegate, name text field.delegate equals self, and also use this delegate for our view controller, so UI text field delegate. We got rid of this error, and now we will use the text field should return delegate method, which I'm going to place at the end. And what we are going to do is to check if everything is working, let's resign the first responder so that we get rid of the keyboard when we click on return. So let's say text field resign first responder, and we have to return something here, so let's return yes, so that it's not yes anymore, it's true now. So let's return true so that the text field should return, and that the text field accepts when someone presses the return button on the keyboard. So let's fire our app up, and we see that there is in fact a table view. We've got our header view. What we forgot is to add our text field to the header view. So let's say header view, add subview name text field. And now when we run our app again, we should also see our text field. When we click it, we get a keyboard, and when we click return, the keyboard hides again. Well, not bad for a start. Now what we're going to do next is adding the name that is written in our text field to the data source. So how can we do that? We will do this in the text field should return delegate method. So we will call our data source object and say add object, as we would usually do it with a mutable array, and add the text field dot text property. So we add text property of the text field. Now notice that when I'm going to run the app now, it should actually work, but when I press return, I get an error, and it cannot be nil, the compiler says. So what can we do about it? Actually, it has something to do with the type safety of Swift. So we have to cast this value we get from text field.text to a string using the cast operation as string. So when we now run the app, we can just enter something, hit return, nothing happens, and that's what we wanted, because we wanted to get rid of this error first. Now let's save it to we have saved it to our data source. We can now say that we want to reload our table view. So let's say TableView.reload data. And when everything is reloaded and we can see our name in the table view, then we can clear our text field so that the next name can be written in this text field. Now we do not see much at the moment because we did not deal with the self_row_at_index_path method yet. So when I type something in, nothing happens. It reloads actually, but we cannot display anything. So let's start with this with the self_row_at_index_path method. And what we're going to do here is first define a constant with let and call it cell identifier, which is of type string, and we'll give it the string cell identifier, which must be equal to the cell identifier we gave our prototype cell in the storyboard. So again, let's create a cell of type UI table view cell, and now let's say table view DQ reusable cell with identifier, just as we did it with Objective-C, and we will use K cell identifier, and again we have to cast what we get here and say as UI table view cell. Now the usual procedure, as with every self-forward index path, let's check if cell is equals nil. If this is the case, let's initialize the cell using UI table view cell. Table view cell with style and reuse identifiers. So let's use UI table view cell cell style default and the reuse identifier k cell identifier. Now we can configure our cell, and this will just be cell.text equals hello, and then we will use the concatenation feature of Swift using our data source object at index index path.row, and again we will have to cast this to a string, so let's say as string. Just a little reminder, this actually is the same as using nslog and then give place this this element from our data source into this string. So it's actually just another syntax for doing the same thing. All right, now we can return our cell, and if we did everything right, we should see a name as soon as we entered it, and we still get an error. This seems to be related to what I said earlier, that the cell identifier must be the same as we defined in the storyboard. So let's check this again. And as you can see, it seems that although we entered an identifier, it wasn't. So let's paste that in and recheck. Enter something here, and it works properly. Cool. Let's check it again. Works nice. All right, now we have half of the work done. Now we have to handle a click on a table view cell, and actually it is again the same as we did in Objective-C. We will have to use the didSelectRow at index path method of the TableView delegate. So let me paste it in right here. And let's add some code. As you remember, when I clicked on the TableView cell in the demo application, we got a AlertView. But surprisingly, AlertView is no longer available. Well, it is available, but it's deprecated in iOS 8. So what else can we use? We're going to use, as an AlertView, the UI AlertController, which is pretty cool actually. So let's initialize it with an UI AlertController. Using this initializer, give it a title. Let's say this is a message, and the message is well, thanks for clicking. And the preferred style is in this case an alert style. So let's call UI AlertController style alert. And not action sheet. Action sheet is actually also replaced with iOS 8. So, well, now we have a title, we have a message, and we have a style. What we don't have is buttons. So how do you create a button for an alert view? Well, it's pretty easy. You just say add action. That's it. Now let's add, as we can see here, let's add a UI alert action. UI alert action. And what we can do here is give it a title, like close alert view, with a style UI alert action style. I'm going to say default. And now we have a handler. And this is actually something we are familiar to as blocks. but it's named closures within Swift. So for this button, we will not have to do anything because it just closes the alert view. So let's call nil. So let's add the second button, which is also alert, add action, and again UI alert action, open parentheses, and now let's add the title, which will this time be change header color with a UI alert action style default again. And now we're coming back to this header, and this handler is something you know and you're familiar with blocks. A block could give you a parameter like the UI view animation completion block, which was called when an animation was completed. In Swift, these blocks are called closures, and you can access them by using curly braces. Now, when you access such a closure, you have to implement this parameter. You have to do something with it. And I'm opening this this closure now, and we remember that we're going to use we get a UI alert action as a parameter. So I will just give this a name. Let's say alert A. I could also say foo or whatever. I can call this whatever I want. So let me access this parameter, alert action, in my closure. And now I can write my logic here. And what I'm going to do is using a UI view animation, actually, UI view animate with duration, say 2.5 seconds with an animation. And this is actually, again, a block or a closure. But notice that here is no that we have no parameter here in this in this closure. This is the return type of this function. So no parameters. So we can just write our curly braces and say self.headerView.background color equals UI color blue color. And notice that I have added the self in front of header view because we are within a closure. We have to use self to access the properties at the top of our class. Now we have this second completion block here, the second closure, and we notice that again we have a parameter which is a bool. We could now access it and use, let's say, success in our block, and let's write print line animation complete. But we also can write this, don't forget the closing parentheses, but we can also skip this and use the wildcard operator, which is an underscore, if we do not want to use the parameter that is offered by the closure. Well, if you have questions about these closures, please feel free to ask down in the comments. All we have to do now is actually show our alert view. So let's call self present view controller, and we will present our alert controller. It should be animated true, with no completion block this time. All right. And it seems that my closing curly brace was missing. Now, build succeeded, and let's run the application and check it out. We will enter a name, hit return. That worked. Click it. Our alert view is appearing. We can close it, and we can click it again. Say change color. And the background color changed, and we get the notification down here that our animation is complete. Well, that was a lot of stuff packed into one single tutorial, but I think it's a useful exercise to try all that stuff and to see how all the UIKit classes work within Swift and how you actually do the same things you always did, just with another syntax. And there are some cool features like this, like these closures and using or not using the parameters that are given. There is some complexity to it, but I think the longer you work with it, the more you get used to it. So please ask what you would like to see next. I'd be delighted to show you as much as I can. So thanks for watching and see you next time.